In this video, we'll demonstrate how to perform stoichiometric calculations using information from the chemical reaction equation. In this first example, we're asked to calculate the mass of aluminum oxide produced upon complete reaction of 10 grams of aluminum, assuming an excess of oxygen. Now, this information regarding the amount of oxygen is very important. That means we don't have to actually take it into consideration when performing our calculations, only the 10 grams of aluminum. So we're asked to calculate how much aluminum oxide is going to be produced from 10 grams of aluminum. But unfortunately, there's nothing in the reaction equation that tells us how to convert grams of aluminum to grams of aluminum oxide. The stoichiometric ratios, the 4, the 3, and the 2 from the reaction equation are actually referring to the mole ratios. So if we had the moles of aluminum, we could use the stoichiometric ratios to calculate the moles of aluminum oxide. So that means in each one of these calculations, we've introduced a new step. To convert between grams and moles, we're going to need molar mass. So the first step is always to take the information that you've been given, in this case the 10 grams of aluminum. We're going to convert that to moles. And as you can see here, we have carried one extra digit beyond the last significant figure. We were given 3 sig figs for the mass of aluminum, so I'm going to carry 4 sig figs from here on out until the end. Dimensional analysis tells us that we have the right quantity. We're going to take our moles of aluminum and use the stoichiometric ratio of 2 aluminum oxide for every 4 aluminum to calculate the moles of aluminum oxide, and then take the moles of aluminum oxide and convert it to the mass of aluminum oxide using the molar mass of aluminum oxide. Always check your dimensional analysis. In this case, moles of aluminum oxide cancel each other, leaving us with grams. Now, this was a step-by-step demonstration. However, this can be done all in one line. For example, we take our 10 grams of aluminum, convert it to moles of aluminum, convert moles of aluminum to moles of aluminum oxide, and then moles of aluminum oxide to mass of aluminum oxide. And if we check our dimensional analysis, everything turns out right. We have grams of aluminum oxide as our final units. Now we can use the stoichiometric ratios to calculate other things, not just mass of product. For instance, if we start with 10 grams of aluminum, how much oxygen is required? The minimum quantity specifically. We can have more oxygen, it can be in excess, but as long as we have the minimum amount, this reaction will go to completion. So again, we can't go directly from mass of aluminum to mass of oxygen. We have to go by way of moles, which means we're going to, again, have to convert our 10 grams of aluminum to moles of aluminum, and then use the stoichiometric ratio of moles of oxygen per moles of aluminum to find out how many moles of oxygen we need. And then finally convert moles of oxygen to mass of oxygen, this time using the molecular mass of oxygen. Check your dimensional analysis, our final units, and we calculate the mass of oxygen required to react with 10 grams of aluminum. Another example of a calculation we can do, suppose we want to produce 10 grams of aluminum oxide. How much aluminum and oxygen are required to perform this reaction? This is going to require 2 calculations. One to calculate the mass of aluminum, the other to calculate the mass of oxygen. So we start with the information we're given, 10 grams of aluminum oxide, converted to moles of aluminum oxide, then moles of aluminum, and then finally mass of aluminum. And then again for oxygen. Now, if you save the number of moles of aluminum oxide you calculated, you can go ahead and start there and convert the moles of aluminum oxide to this time moles of oxygen, and then finally mass of oxygen using the molar mass of O2. It is important to note that you won't always be converting directly between mass and moles. Sometimes you require an extra step. In this example, we want to calculate the mass of ethyl acetate produced from the reaction of 25 milliliters of acetic acid, assuming excess ethanol. In this case, we don't have a direct calculation between volume of some compound to its number of moles. We have to go through an extra step. We have to take the volume of ethanol, convert it to the mass of ethanol using its density, which has been given, and then use that calculated mass of ethanol for your standard calculations, converting mass into moles of ethanol, then moles of ethanol into moles of ethyl acetate, and then finally converting moles of ethyl acetate into mass of ethyl acetate. If you did everything correct, your dimensional analysis should cancel out to give you grams of ethyl acetate.